Hey folks, this video is showing you how to derive the derivative expressions for inverse trig functions and then a couple of examples with using them. So the first thing is that there's some reminder graphs from last year. You can get through this entire lesson without knowing what these graphs look like, but it's still useful to remember them. So arcsine, arctangent, and arcsecant. And when you take their derivatives, you're going to see that the expressions are positive no matter what value of x. And you can see that the slopes of these guys are always positive. And so that's a good way to remember that those have positive values. So those are the important graphs. Those are the graphs. And then this one actually does come up again. So perhaps write these down and make sure that you kind of know these three of them. The other three have negative slopes. So here are the graphs of arc cosine, arc cotangent, and arc cosecant. And you can see that the slopes are always negative for those graphs. Okay, so we're going to be calculating the derivatives for those, coming up with those expressions. And let's first find the derivative of arc sine x. So just remember that what this means is that y is the angle between negative pi over 2 and pi over 2 whose sine value is equal to x. So you can't take the derivative of this directly, but if you rewrite it as, sine of y, which is the angle, is equal to x, then we can take the derivative of that implicitly. Take a moment, pause the video, and try it. Okay, so sine of y is equal to x. The derivative implicitly looks like that. And so when you solve for dy dx, you get an answer in terms of y. But it's possible to put this answer in terms of x. Here's why. So if I write sine of y equals x. Again, what that means is that y is an angle between negative pi over 2 and pi over 2. So I drew the angle between 0 and pi over 2. Just easy to think about the angle in the first quadrant. And since the sine is equal to x over 1, right, x over 1, I'm putting in the legs as a ratio of x to 1. And that means that I can find the missing side. Take a moment, pause the video, and do that. So the missing side is equal to the square root of 1 minus x squared. And so if I want to figure out what the cosine of y is, you came up with this expression. The cosine of y is going to be square root of 1 minus x squared over 1. So it's just the square root of 1 minus x squared. So making that substitution, there's the derivative expression. So notice that the derivative is always positive for all values of x in the domain. And the other thing I want you to notice is the structure of the derivative of arcsine, where it starts with a constant under the root, and then there's subtraction, and then some expression with x that can be written as a perfect square. Okay, it's your turn to do the same thing, and I want you to find dy dx if y is equal to arc cosine x. It's important to know where these derivatives come from because there's a decent amount of memorization here. Pause the video and try it. So you should have gotten this as your answer. You can see that it's a cofunction and therefore its derivative is the opposite. Makes sense. Do it one more time and show that the derivative of arctangent is equal to 1 over 1 plus x squared. This one comes up a lot. Pause the video, try it. Okay. Finding the derivative for arcsecant x, you do the same thing, but it's a little bit different in your final answer. So let's talk about that one. Secant of y is equal to x. I fill in the triangle. So secant, I'm putting the x here and the 1 here because it's 1 over the cosine. And then I take the derivative implicitly. Here's what we get. And then I solve for dy dx. Here's what I get. And so there's the missing side in the triangle. And so the expressions then for secant y and tan y look like this. Secant y is x over 1, so x, and then tangent of y is square root of x squared minus 1 over 1. And so the product here is just equal to the product of these two. But remember that if you looked at the slope of arcsecant, that the slopes were positive, and if you didn't have the absolute value of x here, x could have been negative, and you would have gotten a negative answer for this. So supply the absolute value to make sure that you're coming up with a derivative that's positive. There is a nice explanation, geometric explanation for that I'm not going through right now. It's a little bit more complicated than what I just did. Okay, so a quick note. Each of these, I could have put the angle in different quadrants. For example, arcsine gives back an angle between minus pi over 2 and pi over 2. So I could have put the angle y right here, in which case I didn't write in the y, but the y is right here. The sine of y would be x over 1, and x would be a negative number here. But the hypotenuse would still be square root of 1 plus x squared, and your derivative was dependent on this value right here. So you're still getting the same result. Okay, we're going to try this with a few examples, but first, these are all of the derivatives that we derived in class, and you need to know them. So take a moment, write them down, make sure that you know how to derive all of them. Okay, we're going to practice with derivatives right now, so let's take a moment to try an example. I want you to find the derivative of arcsine of x squared with respect to x. Pause the video. Okay. So notice it's going to have the structure of square root of 1 minus this argument squared, but there's a little bit more to it because you have to use the chain rule and take the derivative of x squared. So the answer is going to look like 2x over 1 square root of 1 minus x squared getting squared, x to the 4th. Let's try another example. Pause the video, try it. Okay, so here's the structure of derivative of arc cosecant. So it's going to be absolute value of 3x this time, right? And then square root of 3x quantity squared minus 1. But then you also have to multiply by the derivative of the inside function. So simplified, that looks like 1 over absolute value of x here because the absolute value of 3x is the same as 3 times the absolute value of x, and the 3's cancel. So there's your final answer. Okay.